Set the stage. This will go right. One of the things I want you to get out of this class is kind of, we get up in the morning and we walk on the Earth. We are on planet Earth. Some of us saw planet Mars, planet Saturn, planet Jupiter. So there are other planets orbiting our sun. So how did all that get to be? Well, that actually kind of leads to comets. And we'll talk more about the formation of our solar system, but you figure it's not very obvious, but if you were to go out in the universe, not our solar system, not our planet, but if out in the universe, you're going to see a bunch of H. What does H stand for? What element, sorry? Hydrogen. You're going to see a bunch of hydrogen, okay? So one of the things we tried to see the other night when we were out, by the way, lab on Tuesday to see the moon, actually. We're doing back-to-back weeks so the lab is Tuesday. It's called a nebula. Most of space doesn't have anything. No hydrogen, no nothing. Okay? It's pretty sparse out there. But a nebula is rich in something. It's gas particles that were left actually by a star that blew up, generally speaking. So this could be our gas nebula. And these particles, these are a bunch of hydrogen atoms, some oxygen, some heavier elements that actually were left by a star that blew up. So this actually, believe it or not, is kind of how our system of planets and sun started out, is a big old nebula. And again, we're going to talk more about that, but I want to kind of get to comets. So over like 100,000 years or so, this stuff, anybody ever made a snowball in here? Yeah. It's kind of like a snowball. So these pieces kind of came together, these pieces and these pieces, and then the other pieces got bigger. Meanwhile, we had gravity. We've talked about gravity. Gravity kind of made the cloud get smaller or contract, and the biggest thing, the granddaddy of them all, and I went ahead and made it into a sun, the granddaddy of them all was the object in the center, which is ultimately became our sun. Okay? But in the meantime, we had, not everything ended up in the middle, we had kind of these tracks of material. And you can kind of see where that's going.
And you said this is in a nebula?
A nebula, yep, started out as a nebula.
That the sun did?
Our whole planets and the sun started out as one common nebula.
So we always one thing?
It was one cloud. It was one cloud.
Cloud. Okay.
Yeah, one cloud, and then I mentioned snowballs, and so we kind of started getting these objects. Yep. And then here we go. Where does comets fit in? And there's more to this story, but I want to get to comets. So let's see. What is the last planet? I'm trying to go counterclockwise, right? What is the last planet in our solar system?
Pluto.
Not Pluto, because Pluto's a dwarf planet, full-fledged planet. Neptune, okay?
Switch up. Let's make Pluto planet again. He's all lonely out there.
So the thing about Neptune, actually this has to do with Pluto. I'll go ahead and put Pluto out here. Pluto is much more like a comet than it is. It's Neptune. I'll put U for Uranus, S for Saturn, J for Jupiter. It's much more like a comet than any of those other planets. So what is a comet? Well, a comet is still part of our solar system, and this isn't drawn to scale because this nebula actually would have had to come out, and the comet pieces actually were made from the same nebula that our planets were made from, that our sun was made from. It's just like outer reaches. So one of the things we're going to do today when we make a comet, guess what? It's going to be very cold. Okay?
Well, it really doesn't make a comet.
Well, kind of.
Yeah.
So it's comets. We have a bunch of comets out here that's in the plane of starts letter E. Plane of the ecliptic. I'm sure that's going to be on your test somewhere. Plane of the ecliptic. So this board would be like a plane of the ecliptic. We have comets out here that are orbiting the sun. And then we also have comets, and you're going to see on a slide here in a minute, in something called the Oort cloud. And it's this humongous spherical cloud, not in a plane, but it's a spherical cloud with the sun in the center. Okay. So that's kind of, so my point is, and the kind of the title of part 8 is the vagabonds of our solar system. So they were like the little snowballs that never made it to become a planet. They were the miscellaneous things, okay? So we have a set of miscellaneous things that are called comets. We have a set of miscellaneous things called asteroids. The difference between a comet and an asteroid is that an asteroid is not cold. So an asteroid is rocky, but it lacks the icy part. Okay, comets are cold and they have icy parts. So let's see what the slides look like. That's kind of the gist of it. Okay, so comets are leftovers. So hopefully kind of what I said, they're leftovers. They didn't become part of a planet. They didn't fall into material that made up our sun. They have a rocky part, just like an asteroid is total rock. A comet is rock and ice. So this here, you kind of have to get your bearings. Let's see.
Well, a whole lot of arrows.
That is a whole lot of arrows. All those arrows, do they look very orderly to you? No.
No, they everywhere.
They're everywhere. But do you see what the caption is for this blue line? Of course, the thing in the center is our sun. What's the blue line? Neptune's orbit. So of course we're, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. So all of our normal planets are in this figure within that blue line. And then we have the crumblies. So things that are outside of Neptune's orbit are cold in the region cold enough that they could have ices. So that's where your comets are going to be. Yeah, and they aren't very orderly, are they? So we have what's called the Kuiper belt. So two things, and these are terms, I have to go find terms to put on your test. A Kuiper belt is actually the ones that I showed you here that are in the plane of the ecliptic. And the Oort cloud is what I tried to, kind of these random dudes out here. Okay, comets, usually mind your own business, quite frankly. And that is, we don't even know they're there. They're just out there. We can, Pluto. I said already a minute ago that Pluto is more like a comet, so Pluto must be very icy. Okay, so Pluto, if you look at Neptune and Uranus and Saturn and Jupiter, they're what we call gas giants. Not only is the size different between those four planets that are outermost, but they're made of gases, and Pluto's not. So the demotion went something like this. There were, I believe, 3 criteria in 06 that they said that needs to be a planet. And one is that it needs to orbit the sun. Pluto clearly orbits the sun. The others needs to be spherical. And the whole thing about spherical is just had time and gravity to kind of take away the rough edges. The other thing is that in order to be a planet, the object must have cleared its orbit. And if we look if I'm Pluto and I'm orbiting the sun, if we look at my path, I've got crumblies left there, okay? Those crumblies are comet pieces. So it wasn't big enough, or as it was formed, it did not clear its orbit. So that's why Pluto's out. And actually kind of the thing in 06 that thing came to a head was a grad student was looking at the Kuiper belt, which is comets, and he found another object, and he's like, dude, that's the 10th planet. Okay, so an object that was in the Kuiper belt, similar to Pluto, but maybe even a little bit larger than Pluto. So that's how that goes. So comets, here's some pictures of some comets. We'll talk about the tails. Comets have a kind of a circular part. That's what we call the coma. And they have kind of a, do you see 2 tails here? Yeah. Usually one is straight. I think this would be the straight one. One is kind of arched, if there are 2 tails. Comets, they never look, they're no 2 look alike. And the reason it's fizzing like that, by the way, is because the sun is making, it's like an Alka-Seltzer tablet that is going, and it's moving, okay? It's creating that tail. So the thing about comets is comets, usually, most comets we don't care about, but sometimes comets start to orbit the sun and they fizz. They can, as they fizz, they're losing their material, so they only have 100 times before they can, 100 times to orbit the sun before there's nothing to them. Here's another comet, Comet Halley. So comets, if you're going to talk about the anatomy or kind of pointed the structure of a comet, I mentioned the coma. Let's see. This is the coma is the bright part at the head. This thing right here, the rocky part that's fizzing, that's called the nucleus. So around the nucleus is the coma. And then we have a couple of tails. The straight tail, not always do we have a couple of tails. Sometimes we only have one tail. But if it's straight, it's probably a plasma tail. And if it's curvy, it's probably a dust tail. So this is actually showing you of course, the yellow in the center is the sun. We have the Earth orbiting the sun counterclockwise here. Here we're showing now a path of a comet. Now, when does it start to fizz? When it's away from the sun or when it's near the sun? Near the sun, exactly. And then the other thing is, can you see what direction the tail is going? Okay, so this way, okay, the comet's trajectory is coming in here, but look at the tail. It's not, if
It's always pointing toward the sun.
It's always pointing away from the sun.
Away.
Yeah, always pointing away from the sun, exactly. It's not like, you fly like a kite and the tail of your kite goes behind you. Wherever that comet is, that tail is going to be directed in general away from the sun. And one of the cool things about the sun, there's a lot of cool things about the sun, but it has this what we call solar wind. So it's actually blowing particles, and that's what's making that flick away from the sun. All right. Another comet. You can actually see the nucleus. That's pretty cool. Pretty impressive. So you guys know what NASA stands for. I don't know what it stands for, but you know what it is? It's United States, it's not our Space Force, which I don't know, that's a whole nother story. Yeah. But NASA is our space organization. Yes. ESA is the European Space Agency. So if you see at ESA, NASA, ESA is like analogous to NASA.
So that's what NASA work with, is ESA?
ESA is in Europe.
Yes, I'm saying, like, remember you, like, if they can't catch a ride back to Earth,
they
ride with it. So that's what they ride with, right?
Well, they ride with Russia.
Oh, why not?
They don't have one either.
Oh.
That's it, yeah. So more comet pieces. They've been, there's some cool stories about what NASA and ESA and I imagine Russia has done with regard to just kind of poking things in outer space. One of the things they poked in outer space are comets. Actually, if I heard Neil deGrasse Tyson say recently, he's like, well, if you're going to have a space force, he didn't seem opposed to it, but he's not a military sort of guy. But he said, if you're going to do that, let's go ahead and be aggressive with regard to if we have like an asteroid or a comet getting ready to hit the Earth. Let's go ahead and be aggressive and figure out how we can prevent annihilation. So this actually is a comet that they hit, and they wanted to see what sort of results would be, what that would do.
What do you mean they hit it? Like,
what you mean?
They hit it. I'm thinking.
Shot a rocket or what?
Yeah, I think they hit a missile, or they powdered it.
Wow.
And then you can kind of see here the 3 or the 4 frames to kind of show. And I've seen a video that said one of the things they were surprised was that after they hit it, basically it fluffed out and it kind of landed back. It didn't do much to it. They didn't know what was going to happen.
So pretty much one of those comes flying at Earth, we're done. We can't shoot it down with a missile.
And the one thing about, and maybe you've heard this too, if you shoot down with a missile, you make, or you try to shoot down, you make all sorts of little pieces that then.
I know, but then if you do that and it makes a bunch of little pieces, they
Yeah. This one, it didn't break apart at all. It just, yeah.
So we have to shoot it twice.
Yeah.
shoot
Well,
it till it's dead.
One of the thing is to maybe try to escort it and kind of give it a nudge. So I'm kind of for nudges. This was another one, and you can see it's not fizzing. Actually, this was a big hairy deal. How's this go? A spacecraft flew to this comet, and the comet is called PHS151 Sept, and the spacecraft had a lander, and the lander's name was Philae, like love, I think. Okay, so you can actually see here the lander that the spacecraft carried landed on comet. It had solar panels and it roved around for a little bit and then it got in a hole. Okay, that's pretty darn cool. And I believe this was as the comet had orbited the sun and was on its way out.
Has anybody ever been on one?
No people have landed on
Probably
one.
too fast to like honestly.
I don't know. They got there, and actually, comets, but more asteroids. There's this whole, can we mine them because they have some awesome metals and stuff, you know. So they're kind of looking at that. Comets are hard. Comets are like the wild childs, you know, but asteroids are a little more tame. So, but no one's landed on one. This is that same comet, and you can kind of see like a little. I said it wasn't fizzing, but does that look like it's fizzing? It's got a little gas jet. It's got a little tiny gas jet there. And it had this strange shape. So that's a comet. Rosetta was the spacecraft. Okay, so meteor showers have to do with comets. So I think we talked about meteors, the streak, the other day. So like if you're out and you see a falling star, there's no star before where that thing fell from. It just is basically the Earth or a piece of rock or something fell through the Earth's atmosphere and created that quick visual. Just a streak.
Yeah, I've seen two in one night. Like it was like right after one another.
Did you make a wish?
Like one fell and then like not even like 30 seconds after that.
That's
another
cool.
one fell. It was cool.
Yeah, and then some streaks are like long and some are short and some have different colors. It depends on the particle. That's awesome. So here's what it has to do with comets. Okay, let's see. So we said that a comet kind of, how many times can a comet orbit the sun before it's totally fizzed apart? Do you remember? It's a nice round number. 100, yep, 100 times. So each time it orbits the sun, it leaves a little bit of it. Now here's the deal. If it leaves a little bit of it in the path where Earth is going to orbit the sun, then we're going to plow through comet debris. And that creates our meteor showers. And this is kind of trying to show you what a meteor shower might look like. So what's that?
So that'd be cool.
Yeah.
I haven't seen one yet, so.
I haven't seen one that good, but I try. There's a few that actually after this class is over in December, there's the meteor shower that looks like it's coming from the Gemini, the twins, the constellation, and it's got a lot of hits.
My teammate has because we was going, where was he coming from? I think it was coming from like Fort Madison, and I thought I saw the Big Dipper. I'm pretty sure I did.
Yeah.
It was because my teammate has the NASA or the Star Collector, how you say the Star app or whatever. So when you put it up to the sky, it shows everything. So it actually was the Arcades in the sky, and then like on the next of it was just Gemini's. It was tight.
Yeah, that's cool. That's a rush when you're like, so you see it on the app, you're like, oh yeah, I see it in the sky. Yeah, I like that. I agree. In fact, we ought to make that worth 10 extra credit points. If you put an app on your phone and you show me, you get 10 extra credit points.
And we got to post a picture on Canvas.
No, you just gotta show me.
Okay.
Yeah, or show me or tell me
Oh,
about
what's the
it.
app called?
I honestly don't know.
Oh my god.
There's all sorts of
Sorry,
them
no.
there.
Just type in star map.
Right, yeah, so it's, common sense or something.
So here's a famous one. This happened a few years ago. And actually I have a couple slides about this. This is a comet. Comets are named after who finds them, and the two people found them, Shoemaker and Levy. And this is actually called Shoemaker-Levy. Those are two last names, 9. So I don't know if they found 8 comets before this. But they observed this comet, and this comet actually had a close call or an original close call with the planet. You can't tell it, but this is Jupiter. Yeah, close call with the planet Jupiter. And then a few years later, it came back because of how its orbit was, and it had even a tragic call with Jupiter. So this is actually how it's being broken up into pieces, and this is showing you a cloud in Jupiter's atmosphere from the impact. So
Is it a cloud or is it where it went like through the gas and left a hole?
I think if you read it, it's like well, this talks about it says a scar, sort of the scar from the impact of an unknown object. Well, this is an unknown object. Yeah. This is what you these would be the comet fragments that are headed for the planet. So I don't know. I have far too many of these slides. This, the other one wasn't, but this is, let's see what this says about the comet. 105 minutes after impact, dark rings. I don't know. It must have messed with the chemistry, maybe, and gave those clouds some sort of color that they're not used to. Like it had a little burn there. Okay, so kind of switching gears. This could be either a comet could hit the Earth and or an asteroid. And again, we'll talk more about asteroids later. But asteroids are just rocky. Comets are rocky with ice. Both can be bad. Actually, and I think this is still the prevailing theory, that most of the water that we have on the Earth came from comets. Okay, so that's kind of fun.
R.I.P. dinosaurs.
Right? R.I.P. dinosaurs. It's coming up. Yep. So one of the things about impacts, well, we'll put it this way. When we were looking at the moon the other day, did we see all a bunch of craters and stuff? Yeah, we did. The moon's popped up with craters. Now, the Earth went through, it's gotten hit a lot too, but the Earth has wind erosion that kind of makes the craters go away. It has plate tectonics, okay? So the moon doesn't have that. A big impact was they found the crater here-ish, and it was the one that killed off the dinosaurs.
So believe.
Yes, so all evidence points. Kind of along those lines, this is actually part of the evidence that would support that. If you look at different types of elements, like oxygen is an element, hydrogen element, iridium is an element, and iridium is relatively rare, but it is abundant in asteroids. And so there's an iridium deposit. You know how rocks are. This is the oldest rock, this is the youngest rock. Well, about here, when the dinosaurs died, is a layer of iridium. So. And how that would have worked was the impact, like this slide says, would have actually caused clouds globally, and the clouds killed the plants, and the animals that ate the plants died, and the animals that ate the animals died in mass.
Only the things in the water live somewhere.
Yeah, something like that. So here's another one. So that was 65 million years ago. This is actually back in, not this, that one was.
Yeah, that's what I'm saying.
This one was in 1909, I want to say, in Siberia at the time, around World War I-ish, right? I'm bad about that. I think so. There was unrest worldwide, but anyway, a bunch of trees were down, and it's thought that it was probably, I think they're saying now, a comet that basically didn't get to the Earth, but kind of blew up in the Earth's atmosphere, basically.
Dang.
Yeah,
So it almost hit, and then it got into the sky and went.
yeah, yeah.
How many atom bombs is 5 megatons?
5 megatons? I don't know. How many atom bombs would that be? I'm not sure.
I'm just trying to get an idea.
That's a good question.
I mean, it laid all the trees down.
Yeah.
Yeah, but I don't know if that's just one section or if it's a lot bigger.
I have another, well, I don't know if I have an image coming up. This is not that. This is actually in Arizona, and it's a big honking crater that didn't get resurfaced. So it means it's relatively new. So anybody been there on my bucket list? This is again talking about the impact site of the asteroid that began the chain reaction to kill off a large part of the land animals. This is, I guess it's not, it looks like the same photo to me. This goes back to the 1909 event. This actually is one I think I alluded to with dash cams, like in Soviet Union. Yeah, that's what this one is.
I saw another dash cam video, and it was like a bit entering, like when it catches on fire, and it was like the sun was like right outside there. That's how bright it was. I was like,
That's crazy, totally. So this is, what is this? So are we in trouble, basically? Near-Earth asteroids. Think about that. Near-Earth asteroids. Okay? So yeah, so asteroids that are near the Earth, and are they potentially going to hit the Earth? Every day the Earth picks up like tons of mass from little micrometeorites falling through the Earth's atmosphere. That's kind of fun, so we're picking up mass. But the big ones are what we're worried about. And most of the asteroids are small. The big ones are what we're worried about. So with regard to the big ones, this kind of shows you timeline, the small ones, how often do they fall? The bigger ones, how often do they fall? And what would be the consequence? So if you get something that's 10 to 100 kilometers in size, that's when you're going to get your extinctions occurring. And how often does that happen? 100 million years or so. And this is the one in the Soviet Union again. Okay. So Big Brother Jupiter actually, this is kind of showing you how the gas giants out here, remember we have Neptune, Uranus, Saturn, and Jupiter. And especially Jupiter, because of its volume, has over time done a lot to kind of protect us. Okay. Well, we did get through that. So this homework is due Monday. Yeah, and I don't know how many you need to do. Remember, look on that sheet how many you need to do. Yes. What's that?
I think it was 3.
3? Oh, he's thinking 3.
Yeah,
Don't do all of them because I don't want to read them all. Okay, so let us go make a comment. And now, have you guys done like this is going to be like a skit? So, actually, while you're in here, it is a skit. So, in a skit, you have a part, and everybody has a part. So, you guys are the actors, and I am the director. Must warn you, this is the first time I've done this.
Oh no. We're gonna get frozen.
And
I don't know if I should be trusted
extra
with this
line.
one.
Extra line.
I felt safe about last week, but I don't know if that was.
Okay, so let's go to the chem lab, guys. We have to bring our stuff. I think it's safe in here. I just leave it in here. Pick it up on the way back. That's what I do.
You said leave it here?
I would, yeah.
Okay.
Literally freezing.